both temperatures basically work the same way. And we'll talk a little bit about exactly how the mercury worked and what that 1 part in 10,000 means. But you know that if you stick a thermometer in something, and it's an alcohol thermometer, for example, that the fluid is going to rise as the temperature goes up. So there are a couple of things that are the same. You know, water freezes and melts. That's an important point to know. It's 32 degrees Fahrenheit. I don't know if you knew that. And I think this has confused people in the past. When I ask people where water freezes at, they seem to know it's 32 degrees Fahrenheit. But when I ask them where it melts at, they seem to say 212, or they think it's where water boils at. But freezing and melting is the same thing, right? If it gets to be 32 degrees outside, water's going to freeze. But if it was 28 and it's going up to 34 and it goes past 32, that's where water melts or ice melts. So freezing and melting point is the same, 32 degrees Fahrenheit. And it's nicely 0 at Celsius, although again, remember, they don't think Celsius actually made 0 where water freezes. I didn't know that. Okay, we also want to know kind of where water boils and condenses. That's a pretty important landmark that we should know. And on the Fahrenheit scale, that's 212 degrees Fahrenheit. So if you wanted to boil water, you need to make sure you set your stove at something hotter than 212 degrees Fahrenheit. Okay, and it boils at 100 degrees. So I also used it, or learned Celsius as the centigrade, but as you can see, that was confusing to some people in some other languages, so they just used the word Celsius, and we still use the degrees Celsius symbol. Okay, so if I look at the difference between the number of degrees separating water freezing from water boiling, 212 minus 32 is 180 degrees Fahrenheit. So there's 180 increments, 180 graduations, if you guys remember that from last semester. I know I didn't have a lot of you. 180 increments between water freezing and boiling on the Fahrenheit scale. On Celsius scale, it's pretty easy. 100 minus 0 is 100, which is kind of why they used it. That makes a little more sense with the rest of the metric system in groups of tens. So if I want to know how to convert between Fahrenheit and Celsius, I need to know what's called a conversion ratio. And I'm not going to get into a ton of math with you guys, but just know that these two things are the same. Okay, that each degree Fahrenheit is not quite twice a degree Celsius. So if it gets 1 degree warmer on Fahrenheit, it gets a half a degree warmer in Celsius. If it gets 1 degree warmer in Celsius, it gets almost 2 degrees warmer in Fahrenheit. Okay, so there's 180 to 100 degree. But some of you guys know this. I can round that to its least common. And the most reduction I can do with this is a 9:5 ratio. Okay, so if you want to know where that 9/5 ratio came from, that's how we got it. So if I want to convert temperatures, what I'm going to do is this. Okay, let's pick one that I think you should know. Okay, most of you guys probably know because you've had to walk in every day and put your face in front of the machine and it tells you what your body temperature is. So somewhere in the 98.6 degree range is your average internal human body temperature. Well, what would that be in Celsius to somebody that's from a foreign country? Okay, so can I just take 98.6 degrees Fahrenheit and multiply that by the conversion factor 9 or 5/9? And I set it up this way for those of you that I speed through this. We don't have enough time really to get into the conversions, and after last semester, I'm going to cut the math way down this semester, and hope that's comforting to those of you that took me last semester and comforting to those of you that didn't. But what we're going to do is, if I set it up this way, if I put the 9 on the bottom, then the Fahrenheit's opposite, right? If I write this over 1, then Fahrenheit and the Fahrenheit here will cancel, and I'll be left with degrees Celsius. So that's how I know to put 5 on top and 9 on the bottom. But I can't do that because the temperature scales don't both start at the same place, right? Fahrenheit kind of had a 32 degree head start because they both don't start at 0. So if I'm in a race and I want to know who's faster, I can't let one person start 20 meters ahead and they both cross the finish line. I have to make sure they both start at the same place. So when we do conversions from Fahrenheit to Celsius, and again, I'm not going to ask you to do a bunch of this. I'm just going to ask you to memorize some landmarks, and I'll give you 4 of them. Okay, so 98.6 degrees. The first thing we have to do is get rid of the 32 degree head start that it got. So if you're plugging this into your calculator, you might want to make sure that you hit 98.6 minus 32 and then hits the equals button because it'll remember your order of operations. So if you just hit 98.6 minus 32 times 5 divided by 9, it's going to take the 5/9 just times 32 because remember you multiply, divide, add, subtract, whatever that order of operations is. I don't even know if they teach you guys that in math anymore. Okay, so 98.6 degrees minus 32, you'd hit the equal sign and find the difference. Now you know exactly how much change there was in Fahrenheit, and then you can multiply that by the conversion factor. Okay, and again, the Fahrenheits will cancel, and you'll be left with degrees Celsius. And so your body temperature in degrees Celsius is 37 degrees Celsius, and I think you saw that watching the videos maybe. All right, what if I want to go the other way? Okay, so I mentioned this, what if it's really cold outside? And you tell someone it's 21 degrees. Well, what would somebody that understands Celsius? What's 21 degrees Celsius to someone in Fahrenheit? So you can't exactly do the exact opposite. You can't take 21 degrees and add 32 to it, right? You have to actually kind of reverse the order that you do things. So if you're going from Celsius to Fahrenheit, you have to take 21 degrees Celsius and then multiply it by the conversion factor. And you'll notice I flipped them, but that's because, again, I need Celsius on the bottom and Celsius on the top so that the Celsiuses will cancel each other out, and the only unit I'll be left with is Fahrenheit. And then you'll get a number, and then once you get this number, you'll go ahead and add 32 to that, because you got to give 32 Fahrenheit, it's 32 degree head start again. Okay, and so that comes out to about 70 degrees. So your body, or room temperature, most people set their thermostat, my guess is between about 68 and 72, where depending on if it's summer or winter, but 21 degrees Celsius is about room temperature, 70 degrees. Right? Now there's one other scale that we're going to add to this, and it's a simple scale if you understand Celsius, but we're Americans and so we understand Fahrenheit better, so it's still probably a weird scale to us. So we've still got 32 degrees and 0 degrees for water freezing, okay? But what we notice about 0 degrees Celsius, and what Celsius also noticed, which is why he counted backwards, is that negative numbers are kind of a pain in the butt to work with, okay? And it could be, negative Celsius isn't quite negative Fahrenheit yet, but if it's negative Fahrenheit, that's really cold. Okay, but that means that the temperature can get below 0 on Fahrenheit scale, and it can get below 0 on Celsius. Well, shouldn't 0 actually mean 0? I mean, shouldn't 0 represent nothing? So what is the point where there's no temperature? Okay, and we'll get to what temperature is in a moment, but what's the absolute rock bottom temperature can get where everything freezes, okay, where all matter stops moving? And we'll get to that. And that's not okay, by the way. That's 0 Kelvin. They don't put a degree symbol in front of Kelvin. So you'd say 32 degrees Fahrenheit, 0 degrees Celsius, but you don't really say 0 degrees Kelvin. You just say 0 kelvins. And I know that sounds weird, but that's what it is. Okay. And if you watch the videos, you remember that it's about 273 degrees Kelvin is 0 degrees Celsius. So water freezes at 32 degrees Fahrenheit, 0 degrees Celsius, and 273 degrees, or 273 kelvins. Right? So each Kelvin increment is a Celsius increment. So that's kind of nice. It's a 1-to-1 ratio. So if I add 273, again, if I give this one a little bit of a head start, if I go up 100 increments to where water boils, then it boils at 373 kelvins. Okay, now it's a little bit of a weird temperature scale to use, but you're going to need it when we talk about things like air temperature and air pressure and volume of gases, which we're going to get to later this semester. Okay, the Fahrenheit scale works pretty good because, again, just like Fahrenheit did, what's 0? The coldest day maybe in northern Europe. Okay, well, a cold day in Kansas is pretty close to 0, and a hot day in Kansas is pretty close to 100. So for 0 to 100, those temperatures make a lot of sense to us. So Fahrenheit scale makes sense. But if you get above, what a hot day in Kansas is, then you get to 180 degrees or 375 degrees when you cook something that gets pretty hot. Celsius makes sense with the divisions by 10, and again, if it's closer to 0, it's really cold out, but again, it can get below 0 Celsius, and if it gets up to 37, it's going to be a really hot day out. That would be a 100-degree day. So we'd only use a fraction of the Celsius scale for most of our, just taking temperatures on a daily basis readings. So Kelvin wouldn't be nobody would go out and be like, whew, it's 285 degrees today. Okay, well, what's that? It's just 12 degrees Celsius, so double that, 24 plus 32, it's only 50 degrees outside. All right, so that's kind of the Kelvin scale, and I just wanted you to be aware of it. All right, 1 degree Celsius is 1 Kelvin. So to get to Kelvin, all you have to do is, once you figure out the Celsius scale, all you have to do is add the 273 degree head start it gets. And then to go backwards, if I'm given Kelvin and I want to know Celsius, then you just, whoops, that needs to be a subtract. Okay, you'd actually Kelvin minus 273 degrees. So you have to get rid of that 273 degree head start. You to know, there's only going to be 4 of them. Again, we're going to skip the math. You can thank me later. We should know where water freezes. And I'm afraid just because it's kind of an easy question. I usually don't like to be a jerk about this, but there's going to be a question that says water freezes at, and your choice might say 0 degrees Fahrenheit and 32 degrees Celsius. So you do need to keep together the 0 and the Celsius, the 32 and the Fahrenheit. Okay, we know that water boils at 100 and 212, so hopefully that's not a whole lot of memorizing for you. Some of you probably knew this already. Some of you might have known the 212 degrees Fahrenheit. I notice people have a lot harder time with the boiling point than they do the freezing melting point. Okay, but you should know room temperature or a nice day outside. 70 degrees Fahrenheit would be 21 degrees Celsius, and you should probably know your body temperature. So if we switch the scale on the temperature thermometer things when you walk into school, they'd say 37 instead of 98.6, or depending on how far away you are, 97.2 or something. Okay, those are the ones I need you to know.